So hello everyone, welcome to my YouTube channel. So today's video is completely based on CBSE class 9 and I have tried to cover these topics. So let's start. So latent heat. The definition of latent heat is the heat energy which has to be supplied to change the state of a substance is called latent heat. That means by applying this, the state of a substance will be changed. Okay. So let's see and let's try to understand this with the help of some example. Okay, so suppose we can convert ice into liquid water. Okay, or we can convert liquid water into ice. Okay, that is a reverse process. So by doing this, we have to apply some latent heat. Okay, now the question arises, why the latent heat does not cause any rise in temperature of the substance. So the simple answer is that the latent heat that we are supplying, okay, it is just for overcoming the forces of attraction between the particles of the molecule. That means you are applying a heat and that heat will be used up by the molecule, okay, by the particles of the molecule to overcome the attraction or the force of attraction between them. So there is no chance of increase of kinetic energy by applying latent heat. Okay, that is why the temperature does not change, it remains the same. For example, if you apply the latent heat in a ice, so what is going to happen? The ice will be converted into water, but the temperature of that particular water will be 0 degree Celsius. Okay, that means there is no change in temperature, only a change in the state. So now latent heats are of two types. One is latent heat of fusion and the other one is latent heat of vaporization. So first of all, what is the definition? Latent heat of fusion. Fusion is nothing but the conversion of a solid into liquid. Okay, that means from ice to water. So the definition is quite simple. That is, the latent heat of fusion or melting of a solid is the quantity of heat that is in joule, okay, required to convert 1 kilogram of a solid at its melting point to liquid without any change in temperature. So we don't change the temperature, okay, we just change the state of that particular solid into liquid. So a very famous example is the latent heat of fusion of ice. Okay, so ice can be converted into water, but the temperature will remain 0 degree. For that, we have to apply that much of heat, that is 3.34 into 10 to the power 5 joules into 10 to the power 5 joules. This is a very important number. Okay, so this much of heat we have to apply, okay, or we have to supply to change the state of 1 kilogram of ice. That means we have to convert that ice into the corresponding water. So the latent heat of fusion of ice is nothing but this number, that is 3.34 into 10 to the power 5 joules. So a very common question and a very important question also, why we hold when we hold a piece of ice in our hand, it feels very cold. So what is the reason? Very important question from the exam point of view. See, when we hold a piece of ice in our hand, okay, what happens? This ice melts. That means there is a change in state. All right, so for this change in state, that ice needs a latent heat of fusion. Okay, the ice needs a latent heat of fusion. So from where does it gets that latent heat? Obviously, it gets the latent heat from our palm as well as from the atmosphere. So a heat is released from our hand. So that is why we feel cold. That is why we feel cold when we take or we hold a piece of ice in our hand. Again, I am repeating this. We hold a piece of ice in our hand. Okay. See, the ice will be converted into water, and for this conversion, this ice needs a latent heat. From where it will collect the latent heat? Yes, obviously it will collect the latent heat from our palm. So that is why a heat is lost from our palm. So by this reason we feel cold. Okay, if we hold a piece of ice in our hand. Now, point number 2, that is latent heat of vaporization. What is latent heat of vaporization? Very easy. You can see the name and it is very clear from its name itself. That is, the latent heat of vaporization is nothing but similarly the change in the state. That is, in this time, the changes from liquid to gas. The changes from liquid to gas. Okay, that is what we call vaporization. All right. Now, the definition, look at the definition. Same, it's a heat, it's an amount of heat that will be convert a kilogram of liquid into its corresponding gas phase. Okay, so during this process, again there will be no change in temperature, only the change in state will happen. Okay, and it is very obvious that the amount of this heat will be somehow more than the latent heat of fusion. Okay, where we converted ice into water or any solid into liquid. So here a liquid is being converted into gas, so that is why it has been found the latent heat of vaporization is somewhat 22.5 into 10 to the power 5 joules. Okay, so to convert 1 kilogram of any water, okay, to the steam at 100 degrees Celsius, we have to apply 22.5 into 10 to the power 5 joules of heat. So this amount of heat is required to convert water into vapor. Okay, this is much more than the previous latent heat of fusion of ice. All right. Now, steam contains more heat in the form of latent heat than boiling water. It's a very important topic. Let's discuss. Suppose while boiling water, if you keep your hand in contact with the steam which is coming out, okay, it is very dangerous. Okay, it is very dangerous. It is more dangerous than the boiling water itself. Now, what is the reason? The reason is quite simple. The reason is, see, the boiling water is in 100 degree Celsius and the steam that is also in 100 degrees Celsius. Now, where is the difference between the boiling water and the steam? The difference is that the boiling water is in liquid form and the steam is in gas form. That means the boiling water has got no latent heat of fusion, sorry, vaporization. Okay, but after getting the latent heat of vaporization, that boiling water has been converted into the gas or the steam. That means the steam is having one extra heat inside it compared to that in that boiling water. So that is why we get injured if we try to touch or if you try to take our hand in contact with the vapor. Okay, that is why it is very, very dangerous. Okay, now sublimation. What is sublimation? Sublimation is nothing but the conversion of solid to vapor, direct conversion. That means the solid will directly go into vapor state, or similarly vice versa as also, the vapor can be converted back into solid directly. Okay, so this type of processes are called sublimation. Okay, so you have to note that the changing of solid directly into vapor or gas is called sublimation. The changing of vapor directly into solid is also called sublimation, which I have already told. The solid that undergoes sublimation is called sublime, and the solid substance by cooling, okay, what we getting back from that vapor can also be converted into solid. So that vapor, if you convert the vapor into solid, that solid substance will be called sublimate. Okay, now we have to see some example of this. See, there are so many compounds which, or substances which can undergo this sublimation. Some common example are ammonium chloride, iodine, camphor, ammonium chloride, iodine, camphor, naphthalene, and anthracene. Okay, another very solid example, a very famous example is solid carbon dioxide. Okay, solid carbon dioxide. So carbon dioxide can be converted into solid. We call it dry ice. Okay, so solid carbon dioxide is also called dry ice. Okay, dry ice, because this can sublime. Okay, this can sublime to form carbon dioxide gas directly from that solid. Okay, some applications of this sublimation. See, we are having a solid substance. Okay, this is solid iodine. This is solid iodine. What we can see? We can see simple thing that it changes directly into gas from solid. So this is a very common example of sublimation. Okay, and see, this is a stage program, and at the bottom there are some fumes. So these kind of fumes are created by using dry ice, that is nothing but solid carbon dioxide. Okay, and another example of sublimation is the sublimation of ammonium chloride. Okay, so this is the experiment basically. So what we have done, we have taken some solid carbon dioxide in a china dish or in a watch glass, and we have covered it with an inverted funnel. We have covered it into with an inverted funnel, and at the mouth we have kept some cotton plug. Okay, so that nothing can go out of the system. So now what we will do, we will heat the mixture with the help of a Bunsen burner, and what we will observe that this ammonium chloride will be directly converted into gas. Okay, but somehow at this position, when it reaches this position, what will happen? The temperature is low at the upper portion. At the upper portion the temperature is low. That is why what will happen, that gas of ammonium chloride will be converted into the solid once again. Okay, because that's a reversible process. Now, so these things that you are watching is nothing but solid solid ammonium chloride. Okay, which has been converted back into solid ammonium chloride. So this was the solid ammonium chloride. It has converted into gas, and when it reaches there, it cools down and goes there as a solid. Okay, so by this we can prove the sublimation property of ammonium chloride. Now the triangle, see, very important. These things we have just discussed. suppose we are having a solid. Okay, so if we freeze the solid or we melt the solid, that means we apply some heat, the solid will be converted into liquid. Similarly, if we freeze the liquid, that means we decrease the temperature, the liquid will be converted into solid. Similarly, if we are having some liquid, okay, and we apply some heat, okay, that means boiling, so that liquid will be converted into gas. The liquid will be converted into gas. And similarly, the reverse process, that is, if we decrease the temperature, that is condensation, what will happen? The gas will be converted into liquid. Similarly, solid and gas has got one more relation, that is sublimation. Okay, by applying heat, solid can directly be converted into gas, or if you lower the temperature, the gas can directly be converted into solid. Okay, so this is the nice triangle by which we can show the property of the conversion between the states of matter. Okay, that's it for today. So thank you so much. If you like the video, please like, follow, share and subscribe to my YouTube channel. And that's it. Thank you.